A wooden temple, 67 meters tall, built 1,000 years ago. It's still standing. No nails, no concrete, no cranes, nothing. Meanwhile, that new office building downtown, already cracking. That bridge they built 20 years ago needs major repairs. So, what did these ancient builders know that we forgot? Comment right now. Have you ever wondered how they moved massive stone blocks without machines? What I'm about to show you will blow your mind. Today, I'll reveal the tricks that let ancient Chinese builders create structures so advanced, modern engineers still can't figure them out. By the end, you'll see why we've been building backwards for centuries. For many years, I've been obsessed with one question. How did ancient people build things we can't replicate today? What I found about Chinese builders will change how you think about engineering. I've studied the Yingzhou Fashi Manual, one of the world's earliest building codes, published in 1103 AD by Song Dynasty official Li Jie. That's the world's first construction guide from 1,000 years ago. I've examined joints that held together for centuries without a single nail. I've seen structures that survived earthquakes that destroyed modern buildings. Quick question. When did you last see a 1920s building that didn't need major work? Now imagine a building from 1056 that's still perfect. That's what we're dealing with. We're talking about builders who made the Great Wall. That's 13,000 miles across impossible terrain. The Forbidden City with nearly 1,000 buildings, temples reaching toward heaven, all without nails, bolts, or concrete. Here's what fires me up. We live in an age of throwaway buildings. Structures that need replacing every 50 years, infrastructure costing billions to fix. Meanwhile, these ancient builders created things designed to last forever. You and I are about to uncover secrets that took masters decades to perfect. Techniques so good that modern buildings now copy their methods. But here's the crazy part. We almost lost this knowledge forever. With what you'll see next, challenges everything you think about construction. We'll start with wooden joints stronger than steel. Then walls made of dirt that beat concrete. Finally, how they moved mountains without machines. But first, let me show you something that will flip your understanding of what strong really means. Actually, let me stop right there. Before we go further, I need to show you something that will shatter what you think about construction. Here's the problem with modern building. We're obsessed with rigid connections, steel bolts, concrete foundations. Everything locked in place. What happens? Buildings crack. They collapse in earthquakes. They need constant repairs. We spend trillions fixing structures that ancient builders would laugh at. Why? We forgot the most important rule. Flexibility beats rigidity every time. Ancient Chinese builders understood something we lost. The secret isn't making connections stronger. It's making them smarter. They developed 3 techniques that modern engineers are just rediscovering. Here's the crazy part. These use zero metal hardware. Wait, when you think of strong construction, what comes to mind? Steel beams, concrete, welded joints? Forget all that. I'm about to show you why wood-on-wood connections are actually better. Technique number 1, mortise and tenon joints. Picture a puzzle piece. One has a tab. The other has a slot. They fit perfectly. That's what mortise and tenon joints are, but engineered to perfection. These joints don't fight movement. They embrace it. Earthquake hits, the joint flexes. Wind pushes, the joint absorbs force. It's like shock absorbers built into every connection. Technique number 2, the dugong bracket system. Here's where it gets clever. Ancient builders created wooden brackets called dugong. Think 3D puzzle made of interlocking wood pieces. Each bracket spreads weight across multiple points. It's like having dozens of helpers sharing the load instead of one person carrying everything. Technique number 3, modular construction. But here's the genius part. Everything was designed to come apart. Every joint, every connection, every piece. Why does this matter? When a section got damaged, they didn't tear down the whole building. They just replaced that piece, like Lego blocks for massive temples. So how did they actually do this? The process took master carpenters decades to perfect. First, they cut each piece with mathematical precision. Tolerance is so tight that the pieces cut 500 miles apart fit together perfectly. No measuring tape, no power tools, just pure skill. Second, they tested every joint before assembly. Each connection had to flex exactly right. Too rigid? Building cracks. Too loose? It collapses. Third, they assembled everything like a giant 3D puzzle. No nails, no glue, no metal. Just wood, fitting into wood so precisely that connections got tighter over time. Let me give you numbers that will blow your mind. The Sakyamuni Pagoda in Shanxi province, built in 1056 AD, stands 67 meters tall. That's 22 stories high. It survived some of China's most powerful earthquakes, including the 1976 Tangshan quake that devastated much of northern China. Modern engineers tested this structure. They found something incredible. The structure can flex dramatically, far more than modern rigid towers, helping it absorb seismic shocks. Here's the crazy part. In 2008, a magnitude 8.0 earthquake hit Sichuan province. Modern buildings collapsed everywhere. The ancient wooden temples, they swayed like trees and stayed standing. I remember seeing dugong brackets for the first time. I was at the Forbidden City, staring at wooden connections holding up massive roof sections. I asked the guide, "Oh, where are the bolts? Where are the screws?" He smiled and said, "There are none. Wood holds wood." I thought he was joking. I spent 3 hours examining every joint. Not one piece of metal hardware. Just wood, precisely cut and perfectly fitted. It was like discovering everything I knew about construction was wrong. Here's what will blow your mind. These primitive wooden joints are stronger than modern steel connections. Not just stronger, smarter. Steel connections fail catastrophically. One bolt breaks, the whole section collapses. But wooden joints fail gracefully. They bend, they flex. They warn you before they break. We've been building backwards for centuries. We traded intelligence for brute force, flexibility for rigidity, permanence for speed. Think of it like this. Modern construction is like a bodybuilder. All muscle, but one wrong move and something tears. Ancient Chinese construction is like a martial artist, flexible, adaptive, using the opponent's force against them. Earthquake hits a modern building, 2 freight trains colliding head-on. Earthquake hits an ancient Chinese building. Willow tree bending in the wind. If you think wooden joints without nails is impressive, wait until you see what these builders did with dirt. Yes, dirt. They took sand, clay, and plant fibers and created walls stronger than modern concrete. Walls standing for 2,000 years in Earth's harshest places. But here's the shocking part. These dirt walls perform better than modern materials in ways that will change how you think about building. Before we continue, comment below. Have you ever seen traditional wooden joinery in person? I want to know if this blows your mind like it did mine. If wooden joints without nails impressed you, wait until you see what these builders did with dirt. Yes, dirt. They took the most basic material on Earth and turned it into walls stronger than modern concrete. These dirt walls have stood for 2,000 years in some of the harshest places on the planet. Here's the problem with modern materials. We're obsessed with expensive, energy-heavy solutions. Concrete production causes 8% of global carbon emissions. Steel needs massive furnaces and mining. What do we get for destroying the planet? Buildings that crack after 20 years. Foundations that shift. Walls that can't control temperature. We're literally killing Earth to build structures that work worse than 2,000-year-old dirt walls. Stop for a second. Think about the most durable thing you own. Your car rusts out in 15 years. Your house? Foundation needs work in your lifetime. Your phone? Obsolete in 2 years. Now imagine building something from dirt that lasts 2,000 years. Sounds impossible? That's what I thought, until I saw the proof. Ancient Chinese builders understood something we forgot. The best building materials aren't the strongest. They're the smartest, rammed. Earth works because it copies nature. Think about a riverbank carved by water for thousands of years. The earth doesn't fight the water, it works with it. Absorbs moisture when wet, releases it when dry. Expands and contracts without cracking. That's exactly what rammed earth walls do. They breathe with the environment instead of fighting it. But they didn't just use any dirt. They had a recipe that took centuries to perfect. Material selection. They carefully picked specific ratios of sand, clay, and organic materials. Sand gave structure. Clay acted as natural glue. Organic materials like reeds and willow added flexibility. It's like a recipe, perfected over centuries. Too much sand. Wall crumbles. Too much clay? It cracks when dry. Too much organic stuff? It rots. Get the ratio exactly right. You create magic. Layer by layer construction. Here's where it gets clever. They didn't just pile dirt into a wall shape. They built in layers, each one compacted to precise density. Each layer only 6 to 8 inches thick. Compact it, let it set, add the next layer. This created walls that were basically laminated earth, like plywood, but made of dirt. Each layer reinforced the others, creating something stronger than the sum of its parts. Environmental integration. But here's the genius part. They adapted to local conditions. Desert? More sand and salt-resistant plants. Wet climates? Adjusted clay content and added drainage. Cold regions? Materials that provided insulation. So how did they actually build these walls? Let me walk you through the process. Modern engineers are just rediscovering. First, they dug the foundation down to bedrock or stable soil. No concrete footings, No steel reinforcement, just solid earth-to-earth contact. Second, they built wooden forms, basically molds for the wall. These forms were precisely measured and could move as each section finished. Third, they mixed their earth recipe on site. Everything was local materials within walking distance. No trucks, no factories, no supply chains. Fourth, they filled forms in layers, compacting each one with wooden tools. The compaction was critical. It removed air pockets and created the density that gives rammed earth its strength. Finally, they removed forms and let the wall cure. No artificial drying, no chemicals, just time and natural processes. Let me give you numbers that will blow your mind. In the Gobi Desert sections of the Great Wall, builders used nothing but local sand, reeds, and willow branches. They created walls 9 meters high. That's 30 feet tall. They've stood for 2,000 years in one of Earth's harshest environments. We're talking temperature swings, from negative 40 degree Fahrenheit in winter to 120 degree Fahrenheit in summer. Sandstorms that strip paint off metal. No rainfall for months. Then flash floods, moving boulders. Meanwhile, modern concrete in similar conditions shows serious damage after just 50 years. The concrete in your driveway probably has cracks after 10 years. I'll never forget touching a section of the original Great Wall made from rammed earth. I expected it to feel fragile, maybe crumbly. Instead, it felt like solid rock. I asked our guide how this was possible. He picked up local soil and said, "This dirt has been here for millions of years. We just taught it how to stand up." That simple statement changed how I think about building materials. We don't need exotic materials from around the world. We just need to understand how to work with what's already there. Here's the revelation that changes everything. These primitive earth walls regulate temperature and humidity better than modern HVAC systems. Rammed earth has thermal mass. It absorbs heat during the day, releases it at night, absorbs moisture when air is humid, releases it when air is dry. It's like having natural climate control built into your walls. We've spent billions developing smart building technology to do what dirt walls have done automatically for 2,000 years. We literally forgot how to build with intelligence instead of energy. Think of modern construction like wearing a plastic raincoat. It keeps water out, but you end up soaked in your own sweat. No breathability, no adaptation. Rammed earth construction is like wearing wool. It regulates temperature, it wicks moisture, it adapts to your body and environment. It works with your natural systems instead of fighting them. That's the difference between materials that fight the environment and materials that work with it. Here's something that will blow your mind. A rammed earth wall built in 200 AD has a smaller carbon footprint than a concrete wall built last year. Why? That ancient wall is still standing and performing. The concrete wall will need replacement at least 10 times over the same period. When you factor in total environmental cost over time, ancient building techniques are actually more advanced than modern ones. If building walls from dirt impressed you, wait until you see how these ancient builders solved the ultimate challenge, moving massive stones across impossible terrain without machines. We're talking 400 million cubic meters of earth and stone, blocks weighing several tons each, transported across mountain ranges, deserts, and rivers, all using nothing but human power and clever physics. Here's the shocking part. They were more efficient than modern construction. The Great Wall's construction stretched across dynasties over centuries, but included legendary feats of speed and scale during key reigns. Some major sections were completed in decades, which will take us centuries to build. I'm about to show you exactly how. Before we continue, I have to ask, have you ever seen rammed earth construction in person? Comment below, because most people walk past these structures their whole lives without realizing what they're looking at. If building walls from dirt impressed you, wait until you see how these ancient builders solved the ultimate challenge, moving massive stones across impossible terrain without machines. We're talking about a nightmare that would make modern project managers quit on day one. But these ancient builders didn't just solve it, they did it better than we could today. Here's what we're dealing with. The Great Wall needed 400 million cubic meters of earth and stone moved. That's enough material to build a wall 3 feet high and 3 feet wide from New York to Los Angeles. Twice. Where did they move it? Across mountain ranges so steep that modern roads can't reach some sections. Through deserts where temperatures swing 160 degrees between summer and winter. Over rivers that flood without warning. Modern companies look at projects like this and immediately calculate bulldozers, cranes, and trucks needed. The ancient Chinese looked at the same challenge and said, "We'll use physics." Let me put this in perspective. California's high-speed rail project, 500 miles of track on relatively flat terrain. Under construction for 15 years. Still not finished. Cost so far? Over $100 billion. The Great Wall, 13,000 miles across some of Earth's most difficult terrain. Completed in just 20 years, using nothing but human power and simple machines. Still standing, 2,000 years later. Ancient Chinese builders understood something we forgot. You don't need more power to move heavy objects. You need smarter leverage. They studied physics before we had a name for it. They understood that small force applied at the right angle could move massive weights. They knew coordinated human effort could accomplish what individual machines could not. Most importantly, they understood that moving mountains isn't about brute force. It's about intelligent systems. They mastered 3 techniques that would make modern engineers jealous. Ingenious ramp systems. First, they mastered the ramp. Not just any ramp. Precisely calculated inclines that multiplied human lifting power. They discovered a 1 in 10 slope let 10 people move what normally required 100. Here's the clever part. They built temporary ramps that could be taken apart and moved to the next section. Like having portable infrastructure that followed construction. Human-powered pulley networks. Second, they created pulley systems that would make modern engineers jealous. Using nothing but rope, wood, and bronze wheels, they built systems that could lift multi-ton blocks with human power alone. They understood every pulley doubles your lifting power. A system with 8 pulleys means 8 people can lift what normally needs 64 people. Coordinated workforce management. Third, and this is really impressive, they organized human chains that worked like precision machines. Thousands of workers moving in perfect coordination, each person responsible for one specific task, like having a human assembly line that could adapt to any terrain, any weather, any obstacle. So how did they coordinate this massive undertaking? Let me break down the system modern project managers still can't understand. Strategic quarrying. They didn't randomly dig up stones. They picked quarry sites based on 3 factors: stone quality, proximity to construction site, and transportation routes. They often quarried stones during winter when farm work was slow, stockpiling materials for construction season. Modular transportation. They broke every large task into smaller, manageable pieces. Instead of trying to move one massive block, they cut stones to standardized sizes that teams of 4 to 6 people could handle, like having Lego blocks for massive construction projects. Adaptive route planning. They didn't fight the terrain, they worked with it. River? They built temporary bridges or used boats. Mountain? They found the gentlest slope or built switchback paths. They treated obstacles as puzzles to solve, not barriers to overcome. Let me give you a specific example that will blow your mind. The Great Wall section at Jinshanling required moving stones up a mountain face with a 60-degree slope. That's steeper than most ski runs. Modern engineers calculated this would need helicopters or specialized mountain equipment. The ancient builders did it using pulleys, ramps, and human chains. They carved temporary steps into the mountainside. They installed pulley anchor points at strategic locations. They organized teams who could move 2-ton blocks up this impossible slope using nothing but rope and coordinated effort. The entire section, 10 kilometers of wall across mountain peaks, was completed in just 3 years. I remember hiking a remote Great Wall section where you can still see original construction marks. I found grooves carved into rock faces where they installed temporary pulleys. I found remains of ramp systems cut directly into the mountainside. What struck me wasn't just the engineering, it was the intelligence behind every decision, every pulley point positioned for maximum advantage, every ramp angled for optimal efficiency, every staging area located to minimize wasted effort. I realized I was looking at a construction system more sophisticated than anything we use today, all accomplished using principles you could teach in high school physics class. Here's the mind-bending reality. Ancient Chinese builders were more efficient at large-scale construction than we are today. They completed the Great Wall's main sections in just 20 years. Modern infrastructure projects of similar scale take over 50 years and cost billions more. The Big Dig in Boston, 3.5 miles of highway tunnel, took 16 years, cost $15 billion. Why were they faster? They understood something we forgot. Human coordination is more powerful than individual machines. 1,000 people working in perfect harmony can accomplish what no single machine can match. Think of modern construction like trying to move your house using one giant crane. It's powerful, but if that crane breaks down, everything stops. You need specialized operators, fuel, maintenance, spare parts. Ancient Chinese construction was like a colony of ants moving food. Each individual ant is weak, but the colony can move objects thousands of times, heavier than any single ant. If one ant gets tired, another takes its place. The system never stops. That's the difference between depending on machines and understanding systems. Here's something that will blow your mind. The Great Wall construction employed over 1 million workers at its peak. That's more people than work for Amazon, Google, and Microsoft combined. But here's the crazy part. They had lower injury rates than modern construction sites. Why? Human-powered systems are inherently safer than machine-powered systems. People can think, adapt, and respond to danger. Machines just follow programming. But perhaps the most revolutionary discovery is how they made their buildings virtually indestructible. Moving mountains and building walls is impressive, but creating structures that actually get stronger during earthquakes? That's pure genius. What I'm about to show you will flip everything you think about earthquake-resistant construction. These ancient builders didn't just survive earthquakes. They used earthquake energy to make their buildings more stable. It's a technique so advanced that modern seismologists still can't figure out how it works. But perhaps the most revolutionary discovery is how they made their buildings virtually indestructible. Here's what doesn't make sense. Ancient wooden buildings survive massive earthquakes that destroy modern steel and concrete structures. Buildings that should be fragile are actually the most resilient. I'm about to show you why everything we think about earthquake resistance is completely backwards. Every year, earthquakes destroy billions in modern infrastructure. The 1994 Northridge earthquake, $20 billion damage. The 2011 Japan earthquake, $235 billion damage. Modern buildings with all our advanced engineering still collapse when the ground shakes. Here's what's really terrifying. We're building more vulnerable structures every year. Taller buildings, more rigid materials, more complex systems that fail catastrophically when one component breaks. Meanwhile, ancient Chinese buildings that shouldn't survive earthquakes are still standing after nearly 1,000 years. Something is fundamentally wrong with our approach. Let me ask you something. When you think of earthquake-resistant construction, what comes to mind? Steel reinforcement? Concrete foundations? Rigid structures that can withstand shaking? Forget everything you just thought. I'm about to show you why the secret to earthquake survival isn't strength. It's intelligence. Ancient Chinese builders understood something modern engineers are just rediscovering. You can't fight an earthquake. You have to dance with it. Earthquakes don't destroy buildings with raw power. They destroy them with resonance. When the ground shakes at the same frequency as the building, the structure amplifies the motion until it tears itself apart. Ancient builders solved this by creating structures that could never achieve destructive resonance. They built buildings that absorbed earthquake energy instead of fighting it. They developed 3 systems that modern seismologists are still trying to understand. Flexible joint systems. First, they used joints that acted like shock absorbers. Remember those mortise and tenon connections we talked about? During an earthquake, these joints allow controlled movement. The building sways, but it doesn't break. It's like the difference between a rigid stick that snaps under pressure and a flexible reed that bends with the wind. Strategic weight distribution. Second, they designed pagoda-style architecture that distributed weight in the most stable way possible. Heavy elements at the bottom, lighter elements at the top. Each level could move independently without affecting the others. Think of it like a stack of flexible discs instead of one rigid tower. Self-healing structural design. Third, and this is the mind-blowing part, they created structures that actually get tighter and more stable when shaken. The earthquake energy compresses the joints, making the building stronger after each seismic event. So how did they actually achieve this earthquake resistance? Let me walk you through engineering principles that took centuries to perfect. Multi-level isolation. Each floor of a pagoda sits on its own set of brackets. During an earthquake, each level can move independently. It's like having built-in seismic isolation on every floor. Energy dissipation systems. The wooden joints act like mechanical dampeners. They absorb earthquake energy and convert it into harmless movement. Instead of energy building up and causing catastrophic failure, it gets dissipated throughout the structure. Adaptive resonance control. The most brilliant part, these buildings can actually change their resonant frequency during an earthquake. As joints compress and expand, the building's natural frequency shifts, preventing destructive resonance from ever occurring. Let me give you a specific example that will blow your mind. The wooden pagoda of Fogong Temple in Shaanxi Province, built in 1056 AD, about 67 meters tall, nearly 1,000 years old. This structure has survived over 40 major earthquakes, including the devastating 1976 Tangshan earthquake that killed 240,000 people and destroyed modern buildings for hundreds of miles around. When seismologists studied this pagoda after the Tangshan earthquake, they found something incredible. The building had actually become more stable. The earthquake had compressed the joints, making the structure tighter and stronger than before. Meanwhile, modern buildings in the same region, built with advanced earthquake-resistant technology, suffered severe damage or complete collapse. I was in Japan during a 6.2 earthquake a few years ago. I was staying in a modern hotel, and the building swayed so violently that furniture was sliding across the room. Everyone was terrified. The next day, I visited a 400-year-old wooden temple just a few miles away. I asked the monk if they felt the earthquake. He smiled and said, "The temple danced a little, but it always dances. That's how it stays strong." That simple statement completely changed how I understand earthquake resistance. Modern buildings try to resist the earthquake. Ancient buildings dance with it. Here's the devastating truth about modern construction. We've traded our earthquake survival for construction speed. Ancient Chinese buildings were designed to last millennia. Every joint was crafted to absorb seismic energy. Every connection was engineered to flex without breaking. Every element was positioned for maximum stability. Modern buildings are designed to meet minimum safety codes for 50 to 100 years. We use rigid connections that transfer earthquake energy instead of absorbing it. We build tall, narrow structures that amplify ground motion instead of dampening it. We literally forgot how to build for permanence. We chose speed and profit over survival and longevity. Think of modern earthquake resistance like wearing armor during a boxing match. The armor is strong, but every punch transfers directly to your body. Eventually, the accumulated damage becomes too much. Ancient Chinese earthquake resistance is like being a martial arts master. You don't block the punches, you redirect them. You use your opponent's force against them. You turn destructive energy into harmless movement. That's the difference between resisting earthquakes and dancing with them. Here's something that should terrify every modern city planner. We're building earthquake time bombs. Every year, we construct taller buildings with more rigid materials in earthquake zones. We're creating structures that will amplify seismic energy instead of absorbing it. When the next major earthquake hits, the damage will be catastrophic. Meanwhile, the solutions already exist. They're standing right in front of us in the form of ancient buildings that have survived everything nature could throw at them for nearly 1,000 years. Here's your one-sentence takeaway. Ancient Chinese builders proved that intelligence beats technology every single time. You now know secrets that took master craftsmen decades to perfect. Wooden joints stronger than steel. Dirt walls that outlast concrete. Earthquake resistance through flexibility, not rigidity. Don't let this knowledge stop here. Share this video with someone who thinks ancient people were primitive. Show them what real engineering looks like. Hit that like button if you think we should learn from these ancient masters instead of ignoring them. Subscribe and hit the notification bell, because next week I'm revealing how ancient Chinese metallurgists created steel stronger than anything we produce today, using techniques that modern science is just beginning to understand. Comment below. What other primitive technologies do you think might be superior to our modern versions? I read every comment, and your ideas help shape future videos. The next time someone tells you that newer is always better, you'll know the truth. Sometimes the greatest innovations are hiding in the past.